Like we are discussing in the previous video, Spring Security Framework is built based upon series of filters which are maintained in a chain manner, and each filter has its own roles and responsibilities, and once it done with its execution, it will hand over the logic of execution to the next filter inside the chain. And based upon the configurations that we do inside our application, these filters will be enabled or disabled inside Spring Security Flow while starting our application itself. One such example is if you make CORS and CSRF configurations inside your application, then the filters associated to CSRF and CORS will be activated and they will be added to the filter chain that maintained by the Spring Security. And at the same time, there are mandatory filters also present inside Spring Security Flow, which will be always executed regardless of what configurations you are making inside your application. But how can I validate what are the filters that has been maintained inside my application by the Spring Security Framework? We can really validate what are the registered filters for your application by making two configurations inside your application. One is you have to add an annotation on top of your application Spring Boot saying @enable web security with debug is equal to true. So this will start your application in a debug mode, and at the same time we should also add one more property which is logging.level.org.springframework.security.web.filterchain is equal to debug mode. So this second property indicates framework that I want to log all my logger statements since I am starting in a debug mode. And you can see this is the sample screenshot that will be displayed inside your console based upon a security filter chain that maintained by your Spring Security Framework. So enough of theory, let's try to validate this inside our application. For the same, I will go to my backend application, and you can see I have added an annotation on top of my application with enable web security and a property debug is equal to true. Similarly, inside your application.properties also, you have to add this statement with a property value is equal to debug. And this indicates there is a filter chain maintained by Spring Security and display all the loggers associated with that filter chain since I'm enabling in a debug mode. So let's try to go and see what is there in this filter chain proxy. As you can see, this is present inside the Spring Security Framework. Inside that, you can go and look for virtual filter chain, and there is a doFilter method which has been implemented by Spring Security team itself, where they will try to execute the filters present inside a chain one by one based upon their current position. You can see the current position will be incremented whenever a filter chain is done with its execution, and we will fetch what is the next filter inside the registered filters, and the next filter logic will be called by invoking doFilter method, which is an implementation for that filter. We can validate this as well by putting a breakpoint here. So let's try to go and start your application by going to the main class and selecting debug as Java application. And whatever configurations that we discuss should never be enabled or configured inside a production application. The reason is these loggers will also print some sensitive information like session ID, tokens, and what are the origin values. All such sensitive information will be logged. Due to that reason, it is strongly recommended not to make this configuration inside your production applications. And the same has been printed in the console as well, where Spring Security team is saying do not use in a production system. So now I'll clear this startup log. I'll go to my UI. I'll try to perform login operation with the credentials that I have. Authentication is successful. Let's try to go to the backend console and see what information my Spring Boot application printed on the console. you can see here there is lot of security and sensitive information that it has logged along with your authorization header, which includes your username and password, which is very dangerous to enable in the production system. And at the same time, it also logged what are the current security filter chain that has been configured for our application. And you can see all these filters will be executed one by one in a order defined here. That means the very first filter that will executed is this one, followed by security context persistent filter till to the end of the filter chain. And you can see these two filters got added to the chain because we made configurations related to CARS and CSRF inside our application. And at the same time, basic authentication filter will be added to the filter chain whenever we try to perform authentication and authorization using username and credentials by making a configuration of HTTP basic or form login inside our project Spring Security configuration. So now we are clear what are all the internal filters maintained by Spring Security based upon the configurations that we make and how to validate them by making some changes to our loggers inside our application. Let's try to validate the same one more time by keeping a breakpoint in this method doFilter present inside the class virtual filter chain, which is an inner class inside the filter chain proxy. I'll try to invoke an operation, and you can see here these additional filters will have all the filters configured by the Spring Security framework based upon the configurations that we make. So these are all the filters that has been configured, and every filter has its own order, which we call it as a position as well. And after invoking of a filter, the current position will be incremented to call the next filter in the chain by fetching it from the additional filters list and invoking the doFilter method implementation from that specific filter. So in this way, Spring Security will leverage all the filters configured inside our application one by one in a chain manner. So now we have a clear understanding on the inbuilt Spring Security filters. In the next video, let's try to understand how to write our own custom filter to address our own application business requirements. Thank you and see you in the next video. Bye.